Okay, so got cut off again. I think this is where we were. We were solving this problem. We saw where they had this relationship right here. This was the relationship that they had, the inverse relationship. And we plugged in our numbers. We came out with k equals 14. Now we're coming down here to answer the question. So k equals 14. That means that the volume is going to vary directly with the temperature and inversely with the pressure. And they want us to find the volume. What is the volume? When the temperature is reduced down to 300 kelvins and the pressure is reduced to 100. So they want us to find the volume when the constant of variation is 14, the temperature is lowered to 300, and the pressure is lowered to 100. Okay, well, those are going to cancel out, making this a little bit easier to multiply. All we end up having to do is multiply 14 times 3, and 14 times 3 is 30, 42. Oh no, I'm going to check. I'm going to double check my math. 14 times 3 is 42. Okay, so the answer is, what is the volume? And the volume is written as milliliters of gas. So 42 milliliters of gas would answer the question. Okay, I'm just going to do, I found a couple of other problems, not inverse or not a combined variation, but a couple of other problems that are just inverse variation problems. But let me see if I can find them now. They are here. So I will do a couple of problems and then I will give you your assignment. Okay, so here we go. The time T in hours that it takes a group of volunteers to clean up a city park varies inversely as the number of volunteers V. So T varies inversely as volunteers. Time varies inversely as volunteers. So there's my equation based on this right here. T varies inversely as V. That's how I get that set up. T varies inversely as V. If there are 10 volunteers, so I have a 10 on bottom. 10 volunteers can clean up the park in 6 hours. Okay, then I can use that information to real quickly find my K, multiply both sides by 10, and constant of variation is K. That means that I can now go over here and say, okay, here's my equation for this inverse relationship. How many volunteers will be needed to clean up the park in 4 hours? So this time we know 4, 60 divided by V. Okay, I'm going to multiply both sides by V, multiply both sides by V, and then I'm going to divide both sides by 4. And that means that V is equal to 60 divided by 4. And 60 divided by 4 is 15. So that means that we need, now this says write an equation relating V and T. I did that right here. T equals 60 over V. That's the equation. And again, they're using this constant variation as A, but we would say K is equal to 60. Okay, and then we answered the question and found that 15 volunteers are needed. VOLUNTEERS. 15 volunteers would answer the question to clean the park in 4 hours. Okay, I'm going to clean this up. Kim lives in a suburb and drives to work in the city. The time and hours it takes her to get to work varies inversely as speed. So what am I saying here? T varies inversely as speed. Okay, T varies inversely as speed. When she averages 20 miles per hour in heavy traffic, that's a speed. It will take her 1.5 hours to get to work. Bless her heart, she needs to move closer to work. Nobody needs to drive an hour and a half to work. That's horrible. So you plug in the information that they give you so that you are able to solve for K. Multiply both sides by 20. And I think that's going to be 3 hours. Okay. Or K is 3. If you multiply this side by 20, cancels out. You multiply this side by 20. That's 2 times 15, which is 30. So I think that's what it is. K is 30. Okay. Let me double check my arithmetic again because I could be wrong. 1.5 times 20. Yeah, it's 30. Okay. So I now have my constant of variation is 20. It says how long would her trip take if her average speed is 50 miles per hour in late traffic? Okay, so I'm going to do it up here. So they're changing things on us, but what they're not changing is this constant of variation. That is the same, constant of variation. So time varies constantly as her speed. Okay, or varies inversely as her speed. So this is the equation that we got from finding K. Now all we have to do is plug in this new information, and it says what is the time for her trip if her speed is 50 miles per hour. So time is going to equal 30 divided by 50. And so her time is going to be 3/5, which if you change that to a decimal value, I believe is 0.6. So time was in hours, so it'll be 1/6 of an hour. If you want to find out how many minutes that is, 0.6 hours. We can tell that that's just a little bit more than half an hour, so it's going to be a little bit more than 30 minutes. But if you want to know how many minutes that is, multiply 0.6 times 60. Why? Because there's 60 minutes in an hour. So that's going to be 36 minutes. And just like I said, it is a little bit more than 30 minutes. Okay, so this was the main thing, though, that you needed to be able to do. This part right here. You got 0.6 hours, then you're good. How do we get that? We plugged in 50 into the equation after we found our constant of variation. And that's pretty much it. So check the calendar to see what the assignment is. And good luck. Ask me questions, please, if you have any.